All right, how's it going, guys? We're back again. Today, it's also going to be another blank page of notes. If you guys like Algebra 1, you are going to like this lesson because it actually has very little to do with geometry. It's mostly an algebra lesson. And so we've all done system of equations before. Today, we're going to be doing system of equations, but with circles. And before we get started, if you have APs tomorrow, which I know some of my sophomores do, feel free to take an extension on the homework that will be due on Friday, right? So if you need more time, just send me a message, let me know, and study for your APs, and don't worry about what's due on Friday. You can submit it over the weekend. So let's get started. So system of equations, right? We know graphically the solution to a system is where the two equations intersect. So we've all done linear system of equations, right? If we have two lines, well, how many solutions could we have? We could have usually one solution, right? And that's when the two lines aren't parallel and they intersect once, right? So that intersection point, right, that will be a XY ordered pair. And that XY ordered pair, that is the solution to that system of equations, right? To that system of linear equations. You guys have probably done other systems in Algebra 1, like a parabola line system, or even like an absolute value line system, or maybe two parabolas or two quadratic equations, right? So there's whole kind of different kinds of systems, but today we're going to be doing systems with circles, all right? And getting back to a system of two lines, we can have one solution like that, right? We could also have no solutions, right, if our two lines are parallel. And we can also have infinitely many solutions, right? And that is going to be when one line is coincidental with the second line, right? And then we have infinitely many solutions, right? It doesn't mean any point's a solution, but any point that is on one of these lines will also be on the other line, right? So today we're going to take a look at a system that involves a circle. So we could do like circle quadratics and circle absolute value systems, but we actually do that in Algebra 2. For us, we're only going to focus on circle line systems. So let's think about how many solutions a circle line system could have. All right, circle line systems. All right, so we got a circle here. If we draw a line, right, a line can obviously intersect two times, so we would have two solutions to the system. A line could also be tangent, right? So we could also have one solution. Let's say the line looks like this. Right, the line could also be vertical or horizontal. That's also a system as well, right? Or, of course, we could also have no solutions if the line doesn't intersect our circle. All right, so for these systems we're going to be solving, we're actually going to get 1, 2, or 0 solutions, right? So we can't get infinitely many with a circle line system. So let's take a look at our first system of equations. It's going to be pretty straightforward. And again, very algebra heavy, so I know some of you will like that. So we start with that equation and this equation. All right, so taking a look at this first equation, we should all recognize that as the equation of a circle, right, centered at the origin, because we have both an x squared and y squared, right, and they have the same coefficient. They both have coefficients of 1. And if you take a look at our second equation, right, it's y minus 2x equals 5, so that is going to be linear. We can change that to y equals mx plus b. So when we solve a system like this, we can't really use elimination, right? That's where we add or subtract the two equations, because if we add or subtract these two equations, right, we're not going to be canceling out these x squared terms or y squared terms. So how we're going to solve these is by using substitution. So taking a look here, I would probably solve for either x or y, right, in the second equation, and then substitute it into the first equation. So using the second equation, I'm going to solve for y, because I think that's a lot easier, right? Solving for x, you're going to get some fractions. So solving for y here, we know y equals 2x plus 5. I will take that quantity 2x plus 5, right? Take y out, plug in 2x plus 5. And once I do that substitution, we get x squared plus y squared. Sorry, y was 2x plus 5, so x squared plus 2x plus 5 in parentheses squared equals 25. Right, so we get x squared plus, and make sure you are actually multiplying out 2x plus 5 squared. Right, that's going to be 2x plus 5 times 2x plus 5. And I know you can all do this. 2x times 2x is plus 4x squared. 2x times 5 is plus 10x. We're going to have two of those. So plus 10x plus 10x. 5 times 5 is 25 equals 25. So we have a quadratic equation, right? Because we have x squared terms. So let's combine these x squared terms, make this equal 0, because that is how we solve quadratics. So if I minus 25 on both sides here, right, those just cancel out. And I have 5x squared plus 20x equals 0. So the way we solve quadratics is by factoring. In this case, I can factor out a GCF. Right, so our GCF here is a 5, and they both also have an x, so I can factor out a 5x. I'm left with x plus 4 equals 0. Right, now that it is the product of two different factors, right, we can use the zero product property and tee it off, and we get 5x equals 0 and x plus 4 equals 0. And solving, it looks like we get two solutions, x equals 0 and x equals negative 4. All right, if you felt I went a little quick through this algebra, well, that is all stuff you're expected to know from Algebra 1. So let me know if that's giving you problems, but this is something that you should be very good at, because you all did get hundreds on the Algebra 1 regions, I'm assuming. So that is that. So we have x equals 0 and x equals negative 4. But wait, don't box in those answers because we aren't done, right? We said the solution to a system is the xy ordered pair. So once we have x equals 0 and x equals negative 4, we have to find the corresponding y values with those x values. So of course, I will not use this equation. That will be more complicated, and it actually gives us additional solutions which aren't really solutions, right? Use the linear equation, y equals 2x plus 5, or y minus 2x equals 5 to get the y values. Right, so now I'm going to plug into y equals 2x plus 5. And when I plug in a 0, I get y equals 5. Right, and when I plug in a negative 4, well, I get 2 times negative 4 plus 5 for my y value. So my y value is equal to negative 8 plus 5, and my y value is negative 3. Right, and so these are ordered pairs, so I can write my final solution as 0, 5, and negative 4, negative 3. All right, so I also want to take a look at this graphically and just confirm our solutions on the graphing calculator. So that'll be good practice, just graphing that stuff in. So let's take a look. All right, so on the calculator, we're going to go to menu, or hit the on button, sorry, and let's add a graphing page. And I'm going to graph my linear equation first. So f of x equals 2x plus 5. Right, there's my line. To graph a circle, hit the tab for another equation. And of course, circles are not functions, so we go to menu, graph, we go to our templates, and circle. So in this case, I have the equation of a circle in center radius form. So that's option 1. So that is x minus 0, y minus 0 equals the radius squared. The radius is 5. And here we go. So we said our two solutions were 0, 5 and -4, -3. And both of those look like our solutions. If you really want to double check, you can go to Menu, Analyze Graph, and go to Intersection. So it's pretty cool here. When you do an intersection like this, you actually make a rectangle, and it'll tell you the intersections found in that rectangle. So we just go Menu, Analyze Graph, Intersection. You click the first corner of the rectangle, you click again, and there we go. Menu, Analyze Graph, Intersection, click, click, and right, that was the solution to the system of equations. These two ordered pairs, 0, 5 and -4, -3, those are points that are on both of my equations. All right, so let's go back to this. And let's take a look at our next example. So that first one was pretty straightforward. If you're given the equation of a circle and a line, that's what you do. You solve the linear equation for either x or y, and you sub in into your circle equation. And most of the time, what you're going to end up with is a quadratic equation, so make sure you know how to factor and solve quadratics. Right. Example number 2. I like this one a little better because you actually need to think a little for this one. So number 2 is going to be find the equation of the line tangent to x squared plus y squared equals 8 at the point 2, 2. Right, find the equation of the line tangent to x squared plus y squared equals 8 at the point 2, 2. So while this is mostly algebra, this does involve some circle theorems and concepts that you need to know. So if we're looking for the tangent line, well, let me make a really quick sketch of this. I know I have a circle, right? The radius, let's talk about this circle. I know it's centered at the origin, right? Because it's x squared plus y squared. And what's the radius? So the radius is not 8, right? The radius is the square root of 8. And the square root of 8 is going to be a little less than 3. So we got this circle with that radius, and it's going to pass through the point 2, 2. Right? If you want to confirm that, right, just plug in 2 squared plus 2 squared, right? That does equal 8. So 2, 2 is a point on the circle. So let's think about what a line tangent to the circle at that point has to do. Well, if I draw that line, it might look something like this. And wouldn't this line, if it's tangent, need to be perpendicular to the radius drawn to that point of tangency, right? That was one of our theorems that we talked about, that tangent lines are perpendicular to radii of the circle at the point of tangency. So now that I know these lines are perpendicular, if I can find the slope of this line, right, I know the slope of our tangent line would be the negative reciprocal slope. And once you know the slope and the point that it passes through, you have the equation of your line. All right, so if you want to go ahead and pause the video and try that, you can. So let's take a look. This first line here, I know it also passes through the point 0, 0. So let's find the equation of this line. It's going to be pretty simple, right? The slope will be change in y over change in x, so 2 minus 0 over 2 minus 0. So the slope is 1. The y-intercept is 0. So the equation of this line is just y equals x. And let me do that in a different color. Let me go green here. All right, so that line is y equals x, which means the slope is 1, which means the slope of the line we're looking for, right, this slope has to equal -1. So we're looking for the equation of the line that has a slope of -1 and passes through 2, 2. So our tangent slope will equal -1, and we know it passes through 2, 2. So I'm going to use y equals mx plus b. And from here, again, it's all algebra. So y equals -1 x plus b. Plug into 2, 2. And we get that b equals 4. So the equation of my line is y equals -x plus 4. And you can check this on your calculator again if you want to graph it. To save some time, I will show you graphing it, but I will do it on Desmos just because it's a lot quicker. So let's take a look at this, not this one. But we found our line was y equals -x plus 4. And that was tangent to our circle, which was x squared plus y squared equals 8. And bam, just like that. 2, 2, point of tangency, right? There is our tangent line that passes through the point 2, 2 tangent to the circle at 2, 2. And if you take a look, right, we said our radius was the square root of 8. So square root of 8 is approximately 2.828. All right, moving on. Let's go back to the iPad. Now for example number 3. So for this one, I want us to solve algebraically and graphically. We're going to be solving this system. Y minus x equals -4. And x squared plus y minus 2 squared equals 4. All right. So again, we got a line up here, right, and the equation of the circle as our second equation. So let's take a look at our first equation. Do we want to solve for y or x? It does not matter. All right, so I'm going to solve for y. I'll say y equals x. Actually, sorry, we're going to make this a plus 4. So let's make this y equals x plus 4. And we're going to take this and sub it in for that y in our second circle equation. So subbing in, we're going to get x squared plus x plus 4, right? Sub that in for y, minus 2, all of that in parentheses squared, equals 4. Right, I'm going to combine within the parentheses first, x squared plus x plus 2 in parentheses squared equals 4. And let's expand this out, simplify, and solve the resulting equation. So once you square x plus 2, we should end up with x squared plus 4x plus 4 equals 4. And all right, I guess it's fine, but we get x squared, or 2x squared plus 4x equals 0. And again, we're going to solve this one by factoring out the GCF of 2x. So factoring out the GCF, we get 2x times x plus 2 equals 0. And our two solutions are going to be x equals 0 and x equals -2. Don't forget to get the corresponding y values. So y equals x plus 4. If our x value is 0, then our y value will be 4. If the x value were -2, then the corresponding y value is +2. So the solutions to this system are 0, 4, and -2, 2. Right, so if you like algebra, you'll like this, right? Nothing too crazy. So I want to do just one more problem and show that you can solve for either the x value or the y value, and it doesn't matter. And so for this last one, we're going to solve both. We're going to use both substitutions and just see how that changes things just a tiny bit. Hold on, resume. All right, so last one is going to be x minus 2 squared plus y minus 2 squared equals 10, and 3y plus x equals 18. All right, so again, we're going to take our linear equation and we're going to solve for one of the variables. In this case, I think it's easier to solve for the x term, right, rather than the y term. So I'm going to solve for this one and say x is equal to negative 3y plus 18. So we take that, we sub it into the first equation. So instead of x, we have negative 3y plus 18 minus 2, close parentheses squared, plus y minus 2 squared equals 10. And really, guys, from here, this is an exercise in algebra, all right? We should all be able to do this. So negative 3y plus 16 in parentheses squared plus y minus 2 squared equals 10. All right, so I'm going to do this over. Let's do that on the side. Negative 3y plus 16 times negative 3y plus 16. So negative 3y times negative 3y is positive 9y squared. Right? Negative 3y times 16 is minus 48y. Minus 48y plus minus 48y will be minus 96y. And 16 times 16 is 256. So that is going to be what we get when we square quantity negative 3y plus 16. Squaring this, we'll get y squared minus 4y plus 4. All of this is equal to 10. Combine like terms, we get 10y squared minus 100y plus 260 equals 10. We got this quadratic. Let's make it equal 0. Plus 250 equals 0. And notice we got a GCF again. I factor out of 10. Y squared minus 10y plus 25 equals 0. Inside the parentheses, let's factor. So we think what multiplies to 25 and adds to negative 10? Well, I'm thinking negative 5 and negative 5. So that factors to y minus 5 times y minus 5. And check it out. So in this case, we only get one solution because y equals 5 here and y equals 5. So we found the y value first. So now we take the y value and we can find the corresponding x value. So I'll use the equation x equals negative 3y plus 18. Negative 3y plus 18. Plugging in that 5, I get x equals negative 3 times 5. That's negative 15 plus 18. And now I get the x value. So our solution is 3, 5. So in this case, there's only one solution, right? Because we got the same y value 2 times. So that is it. There's only one point of intersection here. And if you want, you can check on your calculator again. But there we go. Right? And just if you're interested, if you want to stick around, you don't have to. You already finished the lesson at this point. But I just want to show you, let's say you didn't want to solve for x, you like solving for y, right? We can do that as well. We can say 3y equals negative x plus 18, or that y equals negative 1/3 x plus 6, right? Divide the x by 3, divide everything by 3. And we can also take this and sub it in for that y value. So I'm going to do this one a little quick, but squaring the x minus 2 squared, I get x squared minus 4x plus 4 plus negative 1/3x. And what is 6 minus 2? 6 minus 2 is 4, right? Plus 4 squared equals 10. Right, when I square this, I will get 1/9 x squared minus 4/3 x, so minus 8/3 x plus 16 equals 10. All right, so I have x squared minus 4x plus 4 plus all of that equals 10. And this way is definitely much harder, right, because of this fraction. So I'd recommend avoiding that fraction when you can. So this one was definitely smarter to solve by isolating the x value and subbing that in. Right, but this should also be doable. So let's keep going. X squared plus 1/9x squared, right? That's going to be 10/9x squared. Like make that 9/9. So I have 10/9x squared, and adding that and this, what is that? So I can make 4 12/3. So that will be 12/3, and 8/3 makes 20/3. So that's minus 20/3x plus 4 plus 16 equals 20 equals 10, minus 10 on both sides. I can make this plus 10 equals 0. All right, so that's what I get when I combine like terms instead of equal to 0. I really don't want to deal with this fractions, so I'm going to multiply everything by 9, right, to get rid of these fractions. So I'll multiply the left side of the equation by 9 and the right side of the equation by 9. Right, distribute that 9. And I get 10x squared, 9 times 20/3. The 9 and 3 simplify to just a 3, so that's minus 60x plus 90 equals 0. And now when I factor out the 10, I get x squared minus 6x plus 9 equals 0. And finally something easy to factor, right? X minus 3 times x minus 3. And notice I get x equals 3 as my solution. So trust me, if you take x equals 3, you plug it into either any of the equations, but plugging into the linear equation makes it easy. And we will get y equals 5. So there you go. You can solve the system however you want, right? But try to be smart about it and think about what is easier to isolate will result in the easier quadratic equation. But however you cut it, you get the solution as 3, 5. And last thing, let's just check this real quick. Again, I'm going to be doing this on Desmos. So let's take a quick look. X minus 2 squared plus y minus 2 squared equals 10. And our second equation was 3. Oh, I already did this. I already typed this in. Save myself some time. Right, and a point of intersection should be 3, 5. I don't know why it's not showing up as it should automatically pop up, but right, that's our point of intersection, 3, 5. Right, so there is only one intersection point and one solution to the system, and there it is. All right. So that's going to be it for circles. Actually, we are done with circles. Our next unit is going to be involving area and volume. All right, so I'm thinking we should have a test coming up pretty soon. So I will post about that on Classroom once I figure out when is a good date to have it. But that's going to be it. If you have APs tomorrow, good luck. If you already took some APs, I hope you guys did well. All right, I will see you guys next time. Stay safe and see you later.